My next topic is understanding performance and dealing with some of the misconceptions around performance. So first of all, understanding why we care about performance so much. So better application performance is something that directly impacts the user. So it's the time the user sits and waits for the page to load, or the time a developer waits for a build of the system to complete, or a test run to complete, or the time it takes for a business analyst to execute a specific query. So this is kind of directly impacting users. In a public cloud or private cloud environment where you have kind of an infrastructure team, they have customers, and they have like multiple applications or multiple tenants in their environments, and better application performance means their customers are happier. Happier customers means they return, they buy more, they refer more, etc. Right? And lastly, good performance may lead to better total cost of ownership, because if you have, with better performance, you can achieve better resource density. For example, more VMs per host, right? For public cloud, better performance means winning customers over your competitors. So a customer comes in and they test your cloud, they test someone else's cloud, they choose your cloud. For private cloud, it means two things. It means you can do more with your existing hardware or in your existing data center footprint, and you can win more applications or workloads to run on the private cloud versus spending more money on the public cloud. And this is how it goes. So every transaction processing system has a performance envelope, performance characteristic that goes like this. So this is operations per second on the y-axis and latency on the x-axis. It's low load, you get low latency, and you get the best service. So kind of everything is snappy, and you click on it and it just opens, right? If you increase the load, you usually get slightly higher latency, and there is kind of a point in which your system is fully loaded and you get the lowest cost per delivered unit, the lowest cost per page open, the lowest cost per served query, etc. The problem with running your systems close to their performance capacity is that the moment you exceed it, you get in the area that I call omni-pain. They behave very differently in the elastic mode, so between 0 and 100% load, and when they're at 100% load. Every transaction processing system, meaning database, load balancer, storage system, etc., like, all of them have a pretty similar characteristic. And the problem with benchmarks, including storage benchmarks, is that everyone likes to brag about how their system behaves over there, up and to the right, in an area of the curve that no one is using their systems in, right? So if you see a storage vendor advertise an IOPS number, it's usually they usually run their system up there, right? And it's not anywhere close to where their users are using their system, which is in the elastic part of the curve, not in the saturated part of the curve. So to put some real numbers into this, so it's not just a theory, right? We can show that this really happens on real systems. So this is a specific StorPool storage system that can do 2 million IOPS, so it's a fairly small system, as we've mentioned, right? And we can advertise that the system does 2 million IOPS, right? However, no one in their right mind would run it with a workload that it requires 2 million IOPS. Every single one of our customers would run it in that part of the curve, right? So since they're running it in that part of the curve, my question is, does it matter for our customers if we get the system to run, say, 10%, to deliver 10% more IOPS? My answer to that is definitely not, because they're not running the system in that part of the curve. Does it matter to them if we can get it to deliver 100 microsecond latency instead of 150 microsecond latency, which is kind of 30% lower latency? My answer to that is it absolutely matters, because that's exactly the kind of the load profile that they're running the system in. And a lot of we obviously want to have a StorPool. We want to have a system that delivers a lot of throughput. So you could run it at a fraction of its capacity, which is good for overall behavior of the system. But our focus a lot of times is on decreasing latency, not getting more IOPS, right? Because that's the part of the curve that matters. So how do people run storage benchmarks, including in POCs evaluations that people run? So when someone goes out and tries to buy a storage system, what do? They get the system, they run like a synthetic benchmark on it, and they say, yes, the system can do this much, and yes, the system can do that much. These are usually synthetic tests with a very high queue depth, so like thousands of outstanding operations, because they're trying to get the highest number out of that system. And my point here is that's not the number that matters. These tests are often run on hardware configurations which are unlike what will be used in production. Because these are complex systems, it's very hard to translate a kind of an outcome, a performance measurement you did on one set of hardware to a different set of hardware. It's nearly impossible because it's a complex system. It's also very hard to translate a performance measurement you took in one way into application performance. They're very different. We see a lot of shenanigans, especially when someone's trying to use benchmarks as a kind of a marketing tool. Finally, synthetic workloads don't approximate the real world, so let's try and find something better. So when you're doing benchmarking of a solution you're trying to buy, you should find a metric that really matters to your organization. So that metric may be decreased complexity because you're able to run larger databases. It may be increased developer productivity because their test runs run twice as fast, etc. Right? If you can't measure what matters directly, you should find a good proxy for that. So you're running a production application that consists of a database and a load balancer and application server. Maybe these are the three things you want to benchmark, not a synthetic benchmark on your field benchmark on your storage system, right?